Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we're going to solve exponential equations. The first approach we're going to take to solving exponential equations is by equating coefficients. So, if b to the m equals b to the n, so if you have the same base on two exponents, then the associated exponents are equal. So we're going to look at some equations that we solve by using this method. The first one, 5 to the 2x minus 1 equals 125. So one thing we need to know is that our base here is 2x is 5, and 125 can be written as a power of 5. It is 5 cubed. So since 5 to the 2x minus 1 equals 5 to the third power, then we can say 2x minus 1 equals 3. So we can say that 2x equals 4 and x equals 2. Now, when solving exponential equations, there is no need to check your solutions for extraneous solutions. You still may want to check your solutions to make sure you've done your calculations right. But since the domain is all real numbers, then you won't have extraneous solutions here. The next problem we have 4 to the x equals 32. Well, 32 is not a power of 4. It's not 4 to some power. It is 2 to some power. So 32 is the same as 2 to the 5th power. And then we have this 4x over here, so how are we going to make this work? Well, 4 is the same as 2 squared. So 4 to the x can be seen as 2 squared to the x, which we can rewrite. We know when we raise a power to a power, we multiply the powers. So we have 2 to the 2x equals 2 to the 5th, which means 2x equals 5, or x equals 5 halves. So it's not going to always be the case where you have to change one of the exponents. You may have to change both sides of the equation to where you have a common base on that exponent. Let's look at another one. We have 4 to the x minus 2 equals 116. Well, we know 16 is 4 squared. And we can rewrite 1 over 4 squared as 4 to the negative second power. So x minus 2 equals negative 2. If I add 2 to both sides, I get x equals 0. So now we have another property that we're going to use to help us solve. We have natural log of b to the x equals x times natural log b. So when you have a problem where you cannot write one side as using the same base as the other side, then we're going to have to take this approach where we take the natural log of both sides, and then when you have natural log of b to the x, then x comes down as a coefficient. It's one of the properties we talked about in the last lecture. So when I have something like e to the x equals 0.76, I take the natural log of both sides. And for these problems, you're going to need a calculator. And we're going to go ahead and we're going to round to 3 decimal places. But if you are using a computer system, you need to make sure that you read to see exactly what place they want you to round to. It may not be to 3 decimal places. But we take the natural log of both sides. So natural log of e to the x, all that cancels. We can use this approach for bringing down x, and natural log e wipes itself out. But needless to say, x is going to be the natural log of 0.76. Now, that is an exact answer. And if you're doing problems and it asks for the exact answer, then you will leave it as natural log of 0.76. But if they want a decimal approximation, let's say to 2 decimal places, then you need to find natural log of 0.76 on your calculator, and you'll get negative 0.274. Let's look at another one. We have 17x equals 124. Again, 124 is not a power of 17, so let's take the natural log of both sides. Now, in the previous problem, we had natural log e to the x, which was a property, and all that wiped out and left x. Here, we're going to have to use the property we have above here to bring down the x as a coefficient. And then to get x on one side, we have natural log of 124 over natural log of 17. Now again, that is the exact answer. But if you're wanting a decimal approximation, you need to put that in your calculator, and you should get 1.701. So you need to read your directions carefully and see if they want an exact answer or whether they want a decimal approximation. Okay, the next problem we're going to look at is 5 to the x minus 3 equals 135. So 135 is not a power of 5. So let's take the natural log of both sides. Natural log of 5 to the x minus 3 equals natural log of 135. So I bring down that power as a coefficient. And then I can get this x minus 3 on one side by dividing both sides by natural log 5. Then I can get x on one side by adding 3. Now this is our exact answer. But if we want a decimal approximation, we can do natural log 135 divided by natural log 5 plus 3, and you'll get 86.880. So our next problem we're going to solve by factoring. E to the 2x minus e to the minus 2e to the x minus 3 equals 0. You can think about this as e to the x squared minus 2 times e to the x minus 3 equals 0. Okay, we can write it in that manner. Now, if you think about, or if you let y equal e to the x, then you have a similar problem. But if you substitute y in here for e to the x, you have y squared minus 2y minus 3 equals 0. And this should be something that we know how to factor. Y minus 3, y plus 1 equals 0. So what that means is that what we have over here will factor as e to the x minus 3 times e to the x plus 1 equals 0. So e to the x minus 3 equals 0 means e to the x equals 3. We take the natural log of both sides. X is going to be natural log 3 or 1.099. We look at the other one, e to the x plus 1 equals 0, means e to the x equals negative 1. And when you take the natural log of both sides, natural log of e to the x equals natural log negative 1. Now, if you try to put natural log negative 1 in your calculator, you're going to get an error message because you can't take the natural log of a negative number. So for this portion, there is no solution. So the only solution we have is x equals natural log 3, which is approximately equal to 1.099. So remember that Dr. LB is always in. Please come back for more math help.